Welcome. In this video, we will cover part 2 of chapter 14 on water. Water exists on Earth in all three states: solid, liquid, and gas. Throughout the water cycle, water is going to go from one state to the other state, and through these changes, a variety of different contaminants can mix in with the water. We'll begin our look at this diagram with seawater. The seawater is salty. The sun releases energy onto Earth in the form of heat, which will raise the temperature of the seawater until it vaporizes into a gas. Through this process of evaporation, the water will enter into the atmosphere as a gas, where it can mix with all of the contaminants that we discussed in last chapter. When the water hits a high enough concentration in the atmosphere, it can condense back into a liquid and precipitate as rain. The rain enters the mountains, the lakes, the streams, underground reservoirs, where it can evaporate back into the atmosphere or flow back into the sea. During this part of the process, the water can pick up contaminants from fertilizers as well as contaminants that are found in the soils, lakes, and rivers. We can break up the contaminants into three major categories. The first contaminant are the gases. These can include nitrogen, oxygen, and radon, as well as some of the pollutants that we discussed in chapter 13. The next type of contaminant are the dissolved minerals. These include cations and anions like calcium and magnesium, sodium and chlorine, as well as iron salts. The dissolved minerals are important for the properties of water, but too much of them can lead to hard water. The final type of contaminant is organic matter, which includes bacteria and microorganisms, as well as animal and human waste contaminants. Table 14.2 shows many of the substances that are commonly found in natural waters, as well as their source. We can see most of the gases and acids that we discussed in chapter 13 are sourced from the atmosphere, and many of the important ions for human, plant, and animal health are found in a variety of different rocks and fertilizers. Chemical and biological contamination of water presents a serious global health issue. Contamination of water can be divided into two major categories: chemical contaminants and biological contaminants. Biological contaminants include microorganisms that are pathogenic and bacteria. The EPA estimates that 30 million people in the United States are threatened by bacterial contamination of their water supplies. That's almost 10% of the population. And it's also estimated that over 80% of illnesses worldwide are caused by water contamination. We discussed in detail the chemical contamination in acid rain in chapter 13. Sulfur and nitrogen oxides are deposited into the rain through a variety of different sources. This acid rain precipitation can damage the environment by lowering the pH over time of the soil, lakes, and streams. The acid rain also poses health hazards and can corrode metals and dissolve limestone and marble. This chemical equation describes the destruction of limestone with acid. Limestone has a chemical formula of calcium carbonate, CaCO3. When the calcium carbonate interacts with the H+ ions from the acid rain, it breaks the bond between the calcium and the carbonate, forming calcium ions, carbon dioxide, and water. In many places, the wastewater will be released into waterways. When sewage is released into waterways, it greatly increases the biochemical oxygen demand of those water systems. This is because the sewage is filled with high concentrations of organic matter. Organic matter is going to need to decompose further into the base elements like carbon, phosphorus, and nitrogen. This decay can occur in two different ways. Aerobic decay uses oxygen to help decay the molecules, and anaerobic decay does not use oxygen. When this occurs on a lake, it leads to eutrophication, or aging of the lake. This is because the organic matter uses all of the oxygen that's present in the lake to do aerobic decay first. In aerobic conditions, i.e. when oxygen is present, the breakdown of organic matter leads to the following compounds. Carbon dioxide, carbon turns into CO2, so you can see the carbon is building carbon-oxygen bonds. Nitrate ions, nitrogen trioxide. You can see here all of these atoms end up attached to a variety of different oxygens. This is in the presence of oxygen. When oxygen is not present, the substances can break down into in anaerobic conditions. So carbon, instead of forming bonds with oxygen, will form bonds with hydrogen. The same with nitrogen and sulfur, etc. In these conditions, we're producing methane and hydrogen sulfide. Overall, this eutrophication process of going between anaerobic and aerobic conditions is a natural process. But in the presence of human waste, combined with runoff from farms and lawns and other human activity, the process is greatly accelerated and can lead to the dying of lakes, which will have an extremely rancid smell attached to them.